Namaste. Welcome to this channel Chemistry Made Easy by Dr.ARM. We were discussing molecular orbital theory in case of especially heteronuclear diatomic molecules. We have seen the example previous, that is carbon monoxide. Now we will see this example of another molecule, that is HF. So in case of HF, we have to understand what is molecular orbital diagram for this HF, what is bond order of HF, how many lone pairs are there in this molecule, why 2s and 2p doesn't interact with 1s of hydrogen. So in such things will be discussed in this MO diagram. So the molecular orbital diagram for this HF molecule is like this. We have shown the atomic orbitals of hydrogen on this left side of this diagram. The atomic orbitals of fluorine are shown on right side of this diagram, and at the center we have shown the molecular orbitals diagram of HF. The atomic orbital participating in this molecule, in this MO diagram, is only Vs. So the molecular orbital participating in this is only Vs, that is 1s. It is only 1s, and it has energy minus 13.6 electron volts. Similarly, if we consider the atomic orbitals of fluorine, these are 2s having energy minus 40.17 electron volts, whereas the energy of this 2p is minus 18.7 electron volt. So if you see the difference between electron volt, the energy values of this 1s of hydrogen and the fluorine 2s of fluorine, so you will find that the difference is much larger. And we know that if the difference in this energy of the energy levels of 1s of hydrogen and 2s of fluorine is more than 12 electron volts, then there is no interaction between them. So here we are explaining that why 2s of fluorine and doesn't interact with 1s of hydrogen. This is because the energy difference between the 2s of fluorine and 1s of hydrogen is too large. It is not below 12 electron volts, and that is why the interaction is not possible. So we have shown that this 2s as non-bonding molecular orbital. So this is directly transferred to the MO system, and it is called sigma type of non-bonding molecular orbital, that is lone pair. Similarly, this 2p has two pz, px and py orbitals, out of which the 1s of hydrogen has sigma symmetry, that is of A1 type. So it and this pz of fluorine undergoes interaction, that is in LCO, linear combination, and produces this sigma orbital of A1 symmetry, sigma symmetry. Here the px and py orbitals of fluorine have the B1 type of B1 and B2 symmetries, that is are having pi nature, and these orbitals do not have any matching symmetry orbital provided by hydrogen, because hydrogen has 1s orbital. So these two orbitals of px and py are directly transferred to the MO system and called non-bonding molecular orbitals. So they provide only lone pairs. So fluorine has this 1 and these 2, that is 3 lone pairs, and 1 bond pair and no antibonding molecular orbital. And therefore the molecule HF has these 3 types, 3 lone pairs and 1 bond pair. So the structure of HF is like this. So we can have the explanation of molecular orbital in this way. So we will stop our discussion here and we will see the next molecule in the next lecture. So here you will also find that how many lone pairs. We have also explained there are 3 lone pairs. What is bond order here? So we can explain the bond order. What is bond order? There is no such, this is not involved because it is non-bonding lone pair. And this is the only bond pair which provides 2 electrons. So bond order for this molecule is one half of this 2, because there is no electron in the antibonding molecular orbitals. So it is 2. So one half of 2 is 1. So bond order is only 1, means there is only one bond in the HF molecule. So we will stop our discussion here and we will see the next point in the next lecture. So till then, goodbye, see you next time. Please subscribe to this channel and press bell icon and like button. Thank you very much.